What is air pressure? If you ask this question to Google, it will say it is a force exerted onto a surface by the weight of the air. Or it might simply say it is a pressure exerted by atmosphere on the objects within it. But unless and until we don't take the feel of it, we don't really understand what actually does it mean.
So, to have the better understanding of this particular topic, today we are going to study just that. But before that, we are also going to study magnetic forces and electrostatic forces, and after that, we will be studying about pressure. This will be the last part of the lesson, which is part number 4. We have already covered topics before it, and today we will be dealing with this last few topics of the chapter. Before going any further, I would like to remind you what we studied in the last session. We had studied about muscular force, frictional force, and gravitational force. We had covered these three topics in the last session, and today we are going to start with magnetic force. Student, we all have played with magnets either when we were very young, and some might be playing even today. Magnets is very magical thing for a child. But scientifically, if we look at the magnet, there is a force inside it that causes another magnets to attract towards it, or it might be iron thing which gets attracted towards magnet. So a magnet can exert a force on another magnet without being in contact with it. So this is a non-contact force. We know that the like poles of the two magnets repel each other while the unlike poles attract each other. And since it doesn't require any contact, it is called as non-contact force. Now that we have studied about forces, we will be starting with pressure. What is pressure? Pressure is nothing but force acting on a unit area of a surface, that is pressure. And a mathematical relation for pressure is equal to force upon area. So that is pressure. What is unit of pressure? Unit of pressure is, since it is force upon area, unit. Now that we have studied about forces, we will be starting with pressure. What is pressure? Pressure is nothing but force acting on a unit area of a surface, that is pressure. And a mathematical relation for pressure is equal to force upon area. So that is pressure. What is unit of pressure? Unit of pressure is, since it is force upon area, standard unit is Newton upon meter square or Newton per square meter. However, many times we use Pascal as a unit for pressure. This was named after a French scientist, Blaise Pascal. Let us see another application. It is easier to hammer a sharp nail into the wood than the blunt one. And you might have actually experienced this while hammering a nail. Maybe your elders might have hammered the nail, you might have seen them hammering it. You will see that some nails, if their point is blunt one, then it is very difficult to hammer it. So many times we choose the nails which have a very sharp edges. Now that we know few things about pressure and also we know few applications of pressure, we are going to study the pressure in more detail, and this will be considering liquids. So this pressure is exerted by liquids and we are going to study just that. Liquids exert pressure on the surface under its contact. So it might be the base of the container, or it might also be the walls of the container. It exerts pressure in every direction. For example, you might take now that we know few things about pressure, and also we know few applications of pressure, we are going to study the pressure in more detail, and this will be considering liquids. So this pressure is exerted by liquids, and we are going to study just that. Liquids exert pressure on the surface under its contact. So it might be the base of the container, or it might also be the walls of the container. It exerts pressure in every direction. For example, you might take a glass pipe, and at the one end of it you might attach a balloon or a rubber sheet with a string, and you will find that as you increase the water level inside it, the rubber sheet will go on expanding like balloon. And why does this happen? Because of the water pressure that it exerts, and as you go on increasing the height of the column, the rubber sheet or the balloon will go on increasing or expanding. Liquid exerts a pressure also on the walls of the container. This I already said. It exerts pressure in almost every direction, including the walls of the container. So if you can make certain arrangement like this, and if you attach a balloon on one end, you will find that as you increase the water level, the balloon will go on expanding. Why? Because water exerts pressure also on the walls of the container. Liquid exerts equal pressure at the same depth. So if you pierce a hole on the same circumference of the bottle, you will find that the water that pours outside, they fall on exactly same point from the center. If you take a radius from the center, you will find that they are falling exactly at the same distance from the center. Why? Because it exerts equal pressure at the same depth. However, this point has to be considered, has to be noted, that here there is written same word. Why same word? Because at different depths you will find pressure varies or pressure differs. At same depth you will find same pressure or equal pressure, but at different depths pressure will be different. After studying the pressure exerted by liquids, let us study pressure exerted by atmosphere, that is, atmospheric pressure. The envelope of air around us is known as atmosphere. So, if you look here and there around you, you might not see air because these particles are very small. It is even difficult to observe it through microscope, but they are there and we can feel it. So this envelope of air is nothing but atmosphere. The atmosphere air extends up to many kilometers above the surface of air. The pressure exerted by this air is known as atmospheric pressure. Now let us see few interesting facts about atmospheric pressure. Atmospheric pressure is the force of gravity on air in column of unit area. So this, if we consider as unit area, then we count or we measure atmospheric pressure in terms of force of gravity on air in column of unit area. Now let us consider a person standing on some surface. If you calculate, you will find that the air above his head has a mass of 225 kg. In terms of force, it is around 2215 newtons of force just above his head, and we are hardly 60 kg. So just imagine, how can we balance that much of air above our head? Why don't we crush down because of so much force. That happens because inside our body there is equal pressure. It is equal to atmospheric pressure, and this pressure within our body balances the pressure from outside. Now let us see few applications of atmospheric pressure or pressure due to liquids. First is the pressure due to liquids. The pressure at the bottom of the sea is much higher than near surface. So deep sea divers have to wear special suit to prevent their bodies from being crushed, because as we go deeper in water you will find that pressure goes on increasing. For example, the watches that we wear have a pressure, have a water resistance, but they also mention up to which depth they are water resistant. You might see some watches having 30-meter water resistance, so you can go below the water only up to 30 meters. Below that, company don't gives guarantee of the watch, because that watch cannot withhold the pressure or cannot hold that much of pressure below 30 meters, because as we go deeper into the water pressure goes on increasing. So these deep sea divers have a special suit that can prevent their bodies from crushing. Let us see another application. When the plunger of a syringe is pulled out, the space below it increases, and this reduces the air pressure inside. The higher atmospheric pressure on the surface of the medicine forces the medicine inside the syringe, and this is how the medicine is taken into the syringe by doctors or by nurses. So that were the applications, and it was the last section of the chapter. I hope you understood this lesson. If you have any doubts, feel free to ask. See you in next session. Until then, take care. Bye bye.